Okay, this question is asking us to find the root mean square, the RMS of a voltage in this case, but it could be of any function between over a complete period, which for this periodic function is between t is 0 and t is 2 pi over omega, and you have to give your answers 2 decimal places. The formula from the formula sheet is this one here. It's RMS values 1 over the difference between the two limits multiplied by the integral between a and b, or between 0 and 2 pi over omega, of the function squared dx. Now this is in terms of y and dx, so in our case it would be v squared and dt, because t is the independent variable. And another formula that we might need to use at some stage is this one here. So let's give it a go. Now I'm not going to do the whole problem. What I'm going to do is I'm going to do the integral first, otherwise it gets very messy with the square root sign and everything. So I'm going to start off just by doing the integral between 0 and 2 pi over omega of y squared, or v squared in this case, which will be 6 plus 8 cos omega t dt squared. Right, so in order to work that out, I need to multiply out the brackets, so that would be the integral between 2 pi over omega and 0 of, multiplying out the brackets, we will get 36, 6 times 8 cos omega t, and we'll get 2 of them, so it'll be 48 plus 96 cos omega t. Okay, and then we're going to get 8 cos omega t squared, so that's plus 64 cos squared omega t dt. Right, so then we could integrate it. We can integrate 36, that's fine. We can integrate cos omega t, that's a standard integral from the formula sheet. But cos squared, we can't integrate cos squared, it's a product of two functions, it's more difficult. So what we need to do with this term is we need to use this formula up here. So we need to substitute in, so we'll write that as 2 pi over omega to 0. And what we'll get 36 plus 96 cos omega t. And if I replace cos squared omega t using this formula, I will get a half 1 plus cos 2 omega t. Okay, now the half and the 64 will give us 32 rather, 36, so I'll get 32, that's the 1, plus 32 cos 2 omega t dt. And now this cosine term is just a multiple angle, so we can find that from the formula sheet. So let's do the integration. 36 and 32 gives us, what does that give us? That gives us 68, that's right. So we'll get, using the correct notation, 68t when we integrate. Cos omega t, cos becomes sine, and omega t, because it's cos omega t, we get 1 over omega sine omega t. So we'll get plus 96 over omega sine omega t. And from this term here, we'll get a cos becomes sine, and we'll divide by 2 omega, so that will give us a 16 over omega sine omega t. Square brackets, because we've done the integration, but the limits haven't been used yet, so we put them over on the right hand side. Substituting in the limits, t is 2 pi over omega. If we substitute that in there, we'll get 2 pi times 68 over omega. 2 68s are 136 pi over omega. If we substitute 2 pi over omega into sine omega t, then we'll get, the omegas are cancelled, we'll get sine of 2 pi. Sine of 2 pi is 0, so we'll get plus 0. And similarly, oh, I've missed a 2 out there, haven't I? Should be a 2 in. Because cos 2 omega t becomes sine 2 omega t. Missed that out. If I put 2 pi over omega in there, I'm going to get sine of 4 pi, which again is 0. And then if you do the same thing with the sine of 0 is 0, and when t is 0, it's 0, so we'll get a minus 0. So we end up with 136 pi over omega. That's the value of that integral. So it ends up quite neat because of the sines. Next thing to do is 1 over b minus a. What's that going to be? That's going to be 1 over 2 pi over omega minus 0, which is 1 over 2 pi over omega, which is omega over 2 pi. Right, and then I can put everything together. The RMS will be the square root of 1 over b minus a, which I've just worked out to be omega over 2 pi, times the integral, which was 136 pi over omega. Some cancellation there, the omegas will cancel, pi's will cancel, and we end up with the square root of 68. And if you stick that in your calculator, I think it comes out to be 8.25 to 2 dp. But we've got the exact value there as well. Okay, lots in there. We've got the use of the square of a cosine. We've got a similar thing for the square of a sine, if you ever come across that. We've got a definite integral. Make sure the notation is correct. Make sure you're using the right variable. In this case, it's t. Make sure you put the limits on the square brackets over on the right hand side and substitute them in properly. Bish bash bosh.